Good day. This is Bennett, also known as Jeremiah. Today we're going to talk about the clear explanation of proving the proportionality division theorem. If you're interested in Euclidean grade 12, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So, let's begin. Now, before we go ahead and talk about proving, there are these two theories you have to know. The first one is, whenever you've got two triangles, let's just say we've got this triangle, and let's say you've got another triangle. Let's say it's joined with the first triangle. So, this is what we have. So, notice that we have got two triangles that we're focusing on. Now, let's call this triangle A, B, C, the first triangle that we're focusing on, and the other triangle, let's call it AC, and let's call this maybe F. So, I want you to notice that these two triangles are sharing a common vertex. So, they've got a common vertex A. The first theory states that whenever two triangles have got a common vertex, if we take the area of this triangle and divide it by the area of the other triangle, the answer will be the ratio of their bases. Let me demonstrate it. So if we want to get the area of this triangle, it's going to be half of the base, right? The base of this triangle is BC. So it's going to be half of BC times. So now here, there's going to be the perpendicular height. So somewhere here. So let's call it H. So that is the area of the first triangle. Now, if I divide it by the area of the second triangle, let's get the area of the second triangle. So the area of the second triangle is half of the base. The base is CF. So it's going to be half of CF times. Now, notice that they're both having exactly the same height. Notice that this height is not only for this triangle, but it's also for this triangle, because we're only considering the perpendicular height. The formula is actually half base times perpendicular height. So this height is for this triangle and also for this triangle. So as a result, it will also be times height. Now notice what will happen if I divide their areas. Notice that this cancels with this and this cancels with this. So basically we're left with BC over CF. So the answer is the ratio of their bases. So whenever two triangles have got a common vertex, when you divide the area of one by the other one, the answer will be the ratio of their bases. So this is the first theory. Let's talk about the second theory. So the second theory states that whenever we've got parallel lines, so let's just say we've got this line and let's say it's parallel to this line. So now if I draw triangles, let's just say I draw a triangle here. So let's just say I've got a triangle over here. And let's say I've got another triangle. So let's just say I've got another one over here. So let's say we've got triangle ABC. So basically I'm naming this triangle first. And then let's talk about this triangle also. Let's just say this is triangle D. So let's call it triangle DBC. Right? So notice we're looking at triangle ABC and triangle DBC. So this line is parallel to this line. The first theory states that whenever triangles are under the same parallel line and they have the same base, their areas are equal, meaning that the area of this triangle is the same as the area of this triangle. Now, why are they equal? Notice that this triangle and this triangle have got exactly the same base. They are sharing the same base. So BC is a base to this triangle and it is also a base to this triangle. So as a result, they've got the same base. Another thing you need to take note of is whenever triangles are under parallel lines, they've got exactly the same height. So now let me demonstrate it. Notice that if I draw a perpendicular height here, it is going to be the same as if I draw it here or if I draw it here. They're all going to be the same. So no matter where I draw a perpendicular height, they will be the same. So meaning that these two triangles will both have the same perpendicular height. So whenever two triangles or more are under the same parallel lines, they've got the same perpendicular height. So even if I were to draw a third triangle over here, the area of this triangle will be the same as the area of this triangle and the area of this triangle. Why? Because they're all sharing the same base and they've got exactly the same height. No matter where I draw a vertical line, those vertical lines will be the same length. So that is the theory. Whenever triangles have got the same base and they are under parallel lines, they've got exactly the same area because they've got the same base and the same perpendicular height. All the areas are equal because the area of a triangle is half base times height. So notice that because these two are the same, the area has no choice but to be the same. Now let's proceed to the theory. Let's talk about how we prove proportionality theorem. Here is a situation. So you're given this diagram and you're told to prove that AD divided by DB is the same as AE divided by EC. So the first thing you'll do is that you will construct this line. So let's call this H1. So you'll tell them construct line H1 and you'll also construct this height. So let's call it H2. So both these must be perpendicular. And then from there, you'll also construct DC and BE. So this is easy. All you have to do is just to memorize this X and this X. So you tell them construct line H1 and H2, and you also tell them construct line DC and BE. So the next thing you'll do is that you'll focus on this portion. So let's focus on the top part first. So notice the top part is AD, and AD is this length. So what you'll do is that you look for the triangle that contains this length. So that triangle is ADE, or if you want, you can even call it AED. It doesn't matter. So the triangle that contains this portion is ADE. So you will say area of triangle ADE. So now you're going to say divided by, now you'll focus on this part as well. So we have to look for the triangle that contains this portion. So DB is this length. So the triangle that contains DB is this triangle. So you'll say area of triangle, then it's going to be DEB. So what you're doing is that you're taking this as the base of that triangle and you're taking this as the base of that triangle. So basically in this triangle, because it's written AD here, we'll take this as the base, right? So meaning that our perpendicular height will be H1. And then you'll also take this as the base because we have DB here. So now notice that if you take this as the base, the perpendicular height will still be H1. Now the perpendicular height is H1 because if I were to redraw this portion, notice that we're going to have it like this. So if I were to flip it, notice that E will come this side and A will be this side and D will be this side. And then notice this other portion. So this will be triangle DEB. So notice what I've done. I've just turned this around. So if I turn it around, this is how it will look like. So notice that both of them will be sharing the same perpendicular height. And notice that these two triangles have got a common vertex. So the common vertex is E. So you have to have the ability to see this faced this way. So both these triangles have got a common vertex E. So that's basically what we're doing. So you're sort of copying this stuff. So you will say the area of the triangle that contains this base divided by the area of the triangle that contains this base. So you are sort of copying this stuff in a way. So now let's get the area of this triangle. So now if we look at this triangle, notice that we are taking AD as the base because AD is written here. So what you'll do is that you'll say half of the base. So the base is AD. Then you'll say times the height. So what is the height if we take AD as the base? The height is H1. So we're going to say times H1. And then this will be divided by. So now let's get the area of this portion as well. So the area of DEB, right? So notice we are taking DB as the base because DB is what is written here. So if we take DB as the base, remember the height is this perpendicular height, even though it's not inside this triangle. Whenever we've got an obtuse angle triangle, we are still looking for the perpendicular height, but the perpendicular height will be outside the triangle. So the perpendicular height of this triangle, if we take this as the base, is this portion. So we're going to end up having half times. So we took this as the base. So this is going to be DB. And then we're going to say times. Now it's the same height, H1, right? So times h1. Now notice what will happen. Remember the theory. If two triangles are sharing a common vertex, in this case is E, if we divide the answer rather will be the ratio of that basis. So notice what's going to happen here. These two will cancel. So then we'll end up having AD over DB. So notice we have this portion. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement. Just before we continue, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So that is why we are dividing this area by this area, because the triangles are sharing the same vertex and we know that if we divide them we are gonna get this as the answer. So we are done with the left part. So now let's deal with the right part as well. So now we're going to look at this part this time. So looking at this part, notice that we have to look for the triangle that has the base AE. So the triangle that has the base AE is the same triangle, ADE. Or if you want AED, up to you. So we're going to do the same thing. So we're going to say the area of triangle AED. Was it AED? Yep, it was AED. So AED. So now we're gonna say divided by the area. So now we have to look for, all right, fine. This part I'm supposed to say triangle. So area of triangle AED. So now we're gonna say divided by the area of triangle. So now we have to look for the triangle that has EC as the base. Notice that EC is this portion. So the triangle that has it is this triangle, right? So triangle DEC or EDC, up to you. So let me just call it DEC. So now we're gonna find the area of triangle AED. Remember, this time we are taking AE as the base, right? So triangle AED. So let's take AE as the base. If we take AE as the base, notice that the height is now H2, right? So we're taking, so the height will be H2. So now we're gonna say half. So we're gonna say half of the base, which is AE, or if you want, you can take it from here. So half of AE times the height, which was H2. So now we're gonna say divided by. So now let's find the area of this triangle as well. Triangle DEC, right? So this triangle. So the area of this triangle will be half of. So now remember we took EC as the base. So we're gonna say times EC, right? So half of EC times. Now what is the perpendicular height of this triangle? Notice that it is an obtuse angle triangle. If I were to take this as the base, the triangle will actually look like this. So we're gonna have DEC, right? Notice I just flipped it. I'm not taking EC as the base. So notice that the perpendicular height is outside this triangle. And notice that the perpendicular height is still going to be H2, right? But just to cut it short, notice that these two triangles are sharing the same vertex as well. This time the vertex is D, right? So because they're sharing the same vertex, they will both have the same perpendicular height. Notice that H2, if you look at H2 alone, H2 is the perpendicular height of this triangle and also this triangle. So this triangle is an obtuse angle triangle, right? So the perpendicular height will not be inside it, right? The perpendicular height will be outside. So that will be the perpendicular height, right? It is outside this triangle. So then we're going to end up having H2. So that's what we have. So notice whenever these two triangles are sharing the same vertex, in this case it's D, they will both have the same perpendicular height. If I draw this portion, notice that we're going to end up having, let's just draw it. So if I draw it, this is what we have. So now notice that this is triangle ADE. So A will now be this side. So it's going to be ADE, right? And notice this triangle EDC. So C is going to be this side. So I've just flipped it. So notice I just flipped it. So if you flip this part, this is exactly how it's going to look like. And H2. So we're going to have H2. So H2 is the height of this triangle and also the height of this triangle at the same time. So that's what we have. So we're using the same theory again, right? We know that when we divide triangles that have got a common vertex, the answer will be the ratio of their bases. So notice that this will cancel this will cancel this. So now we'll end up having AE over EC. So that's what we have. So there we have it. So now we have gotten this part and this part as well, but we have a problem. We did not prove that they are equal, right? We just got the area of this and divided them and it gave us this. And we also got the area of this portion and we divided it and it gave us this. But we need to prove that they are equal. In order for us to prove that this is equals to this, we just simply have to prove that this is equals to this. If we can prove that, then we're done. It means that this will be equals to this. So how do we prove that this is equals to this? Alright, so I've rewritten this two portion over here. So we have to prove that they are equal to each other. So first of all, we will state that they are, we have to state that they are both equal. Now we have to give reasons why they're equal. So first of all, you will state that this area is equals to this area, right? So we're going to prove that this area is equals to this area and this area is equals to this. So first of all, you will tell them that both these are equal. So you will tell them that they're equal. Why are they equal? They're common. Notice that we have been referring to the same triangle. So you will just say this area, right? You will say area of triangle. So area of triangle ADE is common. So these two triangles are common. So notice that they're common. We've been referring to this same triangle. We referred to this triangle when we were talking about the first portion. And then when we talked about this part, we still looked at the same triangle. So it's basically the same triangle we've been referring to. So you'll tell them that their area is common. It's the same triangle. Now what's left is for us to prove that this area is equals to this area. So we have to prove that the area of is equals to the area of this triangle. So how do we prove it? Remember, these lines are parallel. So if these lines are parallel, what you have to know is, remember the second theory, how that if we've got triangles that are under the same parallel lines, they've got the same perpendicular height, right? So they have the same perpendicular height. Now because they've got the same perpendicular height, and notice if we look at their bases, notice we're looking at this triangle and this triangle. Notice that if we take DE as the base, so if we like to flip this triangle upside down and we take this as the base, so because they've got a common base DE, we're gonna have the same areas because their bases are the same and their heights are the same. So you will tell them that the lower part is equal as well. So you'll tell them that, the area of triangle DEB is the same as the area of triangle DEC. So why are they the same? They're the same because they've got a common base. So you tell them common base. So you told them they've got a common base DE, so we have to specify the base. So remember we took this as the base when we flipped this triangle upside down. So they've got a common base DE, right? And then they've got the same height. So you tell them that they also have the same height. Why do they have the same height? So you tell them they've got the same height. They have got the same height simply because these two lines are parallel, right? So you'll tell them they've got the same height because DE is parallel to BC. So you tell them they've got the same height because, so you can even say because. So because DE is parallel to BC. And there we have it. So we're done. We've proven that these two parts are equal. So if they're equal, it means what they produced are both equal as well. Notice that this produced, it produced what? It produced AD over DB, right? So it produced AD over DB. So it produced that. So this produced AD over DB, and this also produced or simplifies to AC, AE over AC. So AE over CE. So it produced AE over AC. So what I want you to be aware of is, because this produced the first part and this also simplifies to the second part, since they're both equal, what they both produced have to be equal as well. So that is it. So we've proven that they're equal. So there we have it. So they're equal. So what you do is, whenever you've got this type of question, you just have to look for the triangle that produces this base and the triangle that produces this base. So you have to get the areas and divide them by each other. And then you do the same thing. You find the triangle that has this base and this base. And then you find their areas, right? So you find their areas and you divide them by each other. And they will produce the exact same thing because they've got the same vertex. So that's what we have. And then what's left is to prove that this portion is equal to this portion. And it's easy to prove that. Notice that the area is common, right? And for the lower triangles, we just have to tell them that they've got the same height because they're under the same parallel lines. And then they've got the common base, DE. So there we have it. Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.